So in this video we'll be going over algebraic proof, and although this video seems pretty long, we will be going through a series of very common questions that appear on exam papers. Now often in maths you will be asked to prove something mathematical is true for all values. Now though we can sometimes prove something is true by trying a certain number or numbers, it may be just coincidence that it works. In order to prove something is true, you must try using all kinds of numbers. So for example, you need to try small numbers, big numbers, decimal numbers, fractions, negative numbers, irrational numbers, etc. Now, because trying every type of number and every number is going to be very time consuming and near impossible, we can replace a testing number with a variable or a letter and use algebra to allow us to see if a mathematical statement is true. Now it is going to be near impossible for me to go through every single algebraic proof questions. However, there is some sort of similarity with some of the questions and some of the components that you need to prove something algebraically. Now when we're looking at the sum of two things, it's important to recognise that an even number plus an even number gives you an even answer. An even number plus any odd number, or the reverse of that, an odd number plus an even number, the order when you're adding doesn't make a difference, will always give you an odd answer, and an odd number plus another odd number will give you an even answer. Now that is absolutely fine for you to use as part of your claim. Now another part of that is looking at the products of an even number plus an odd number. So an even number plus an even number will give you an even answer. An even number multiplied by an odd number will give you an even answer. And an odd number times an odd number will give you an odd answer. And using that, using the first line and the third line of this little blue sort of bubble that I've created, that an even number squared will give you an even answer, and an odd number squared would always give you an odd answer. Now, as we talked about in the introduction to this video, it's that we're replacing numbers with algebra. So rather than using and substituting numbers, what you need to do is you need to replace that number that you would use that represents any type of number, whether it be a fraction, negative, or anything like that, as either by calling it either x or n. Now, again, it doesn't really matter which letter you call it. As long as you call it a letter, then that is absolutely fine. But you tend to find that majority of mark schemes tend to use the letter n because it represents a number. However, x is another very, very popular letter that's used in algebra. Now, sometimes you might have a problem that involves consecutive numbers. Now, so for example, consecutive numbers could be any consecutive number. So you could use 1, 2, you could use 3, 4, you could even use 43 and 44. And they would represent consecutive numbers. However, if we're going to translate this into algebra, then our starting number, as I've mentioned previously, would usually be the letter n or x. Then the number next to that, the next consecutive number, will be whatever n is plus 1. The next number would be n plus 2. And the next number would be n plus 3. And likewise, if I had to start with the number n, then the previous number would be n minus 1, the previous to that would be n minus 2, and the number previous to that would be n minus 3. So if a question says, let's say looking at two consecutive numbers, and I could use any two of these expressions as you can see in this row. Now if you're talking about two particular consecutive numbers, then I would generally start with the letter n, then move on to n plus 1, and then move on to n plus 2. I certainly wouldn't advise going on to negatives, although it is possible, there's nothing wrong with doing that, but I would say you're less likely to make a mistake if you are dealing with positive numbers. Now the next thing we move on to is consecutive even numbers. Now, because obviously we could have any even number, so again the first even number is 2, we could have 4, we could have 8, we could even have 68, it doesn't really matter which number we're looking for. That to make sure a number is going to be even, it needs to be multiple of 2. So here, rather than starting with n, instead we start with 2n, because if n was any number, whether it be 1, 2, 3, 4, 5, then multiplying by 2 would automatically make it into an even number. So here, if our first even number is 2n, then the next consecutive number will be 2, and then it will be n plus 1. So if I expand the bracket, it would be 2n plus 2. Then the next consecutive number after that would be 2n plus 2, which again, if I expand the brackets, would be 2n plus 4. And obviously going in the opposite direction, that if we start off with a number being 2n, then the previous consecutive number would be 2n minus 1, which again would be 2n minus 2. And then the previous number to that would be 2n minus 4. And again, if you tried typing in the numbers, so 1, 2, 3, and if I substitute the numbers in, so here I've got, when my number is n, my original number is 1, shall I say, then this is going to be 2, then here I'm going to end up with, well, let's start off by using a different color rather. Okay, so let's say n was equal to 1. Then 2n would be 2. Then 2n plus 2, that's 2 times 1, which is 2, plus 2 is 4. And the next one would be 2 times 1, which is 2, plus 4 is 6. And as you can see, these numbers here are consecutive even numbers. Now the same thing kind of applies with odd numbers as well. So I'll just get rid of this just to create a bit more space. So here I'm going to start off with my first odd number being 2n plus 1, because then again that would give me a guaranteed odd number, because an even number plus an odd number, so 2n is always going to be even because it's a multiple of 2, and 1 is always an odd number, and again an odd plus an even will always give me an odd answer. So there is my first odd number. Then the next odd number would be adding 2 to it, so there is my next one. And again, if I want to look at previous values, then that would be 2n minus 1, 2n minus 3. And another type of question that tends to come up in algebraic proof is consecutive square numbers. So again, if I start with my initial number being n, then the first square number would be n squared. The next square number would be n plus 1 squared. The next number would be n plus 2 squared. And then the third number, well, the fourth number I should say, would be n plus 3 squared. And likewise, if we're going for previous numbers, then I'll be taken away from 1, n take away 2 squared, etc. So it's kind of really important that you get the concept of what consecutive numbers are, what they mean, and how to write them algebraically going forward with other types of questions. Another thing that you kind of need to be aware of is when dealing with questions involving multiples, so multiple of 5 is where you're multiplying an expression or number by 5. So if you've got 5n or 5 times anything, any other number, then it's guaranteed to be a multiple of 5. Why? Because you are multiplying by 5. So let's have a look at our first example. So in this question it says that prove that the product of two consecutive integers will always be even. Now before we get started, let's just break down what some of these words actually mean. So the product is just a more mathematical word for multiply. Integer is basically a whole number. So what this question is asking me is prove that when you multiply two consecutive whole numbers that the answer will always be even. Now a typical error what most students would write when answering this question is I think, right, okay, well let's go for 1 times 2, and that's 2 and that's even. And you've got, let's go for 2 times 3, which is 6 and that's even. And 4 times 5, which is 20 and that's even. And you think, right, yeah, so therefore it's even. Now again, that might just be coincidence for the three pairs of numbers that I've used. Is that the same for, let's say, 63 times 64, or maybe minus 5 times minus 4? So again, I need to kind of prove this, and I've got to use all types of numbers, both positive and negative, even though it does say that they need to be whole numbers, but I need to show that they are even. So going back to what we did in terms of the notes just on the previous part of the video, let's show how you can answer this algebraically, and also going through what they'll be expecting in the mark scheme. So here I'm going to start off with two consecutive numbers. So I'm going to start off with n, and the next number would be n plus 1. So whatever number this is, the next number will always be that number plus 1. Now we're looking at the product, so what I'm going to do is I'm going to multiply those two numbers together. Now using algebra, what we've got is we're going to got n and then n plus 1. And then from this, we're going to multiply the brackets, so we've got n squared plus n. Now with this expression that we've got here, and if I just split this page up and I start by writing n squared plus n. Now n can only be odd or even. So if n is odd, then what we've got is we've got an odd number squared plus an odd number. Now an odd number squared will always be even, plus an odd always equals an even number. Now if n was even, then I'm going to have an even number squared plus an even number, and an even number squared gives me an even answer, and an even plus an even gives me an even answer. So for all, whether n was positive, let's say if n was odd or even, the answer when I multiply two consecutive integers will always give me an even answer. So therefore the product of two consecutive numbers will always be even. Now you might be thinking to yourself, do you know what, it was easier using numbers, which may be true, but again you haven't used every single number, and there will be an argument to suggest, well, it might just be coincidence that the 10 pairs of numbers that you've used, or the 12 pairs of numbers, or the 20 pairs of numbers may prove to be just a coincidence. Unlikely as it is what it is. So the examiners will be expecting you to use this type of terminology and this sort of notation to prove any sort of mathematical statement to be true. Now looking at our next question, it says that prove that 4 lots of p minus 3 minus 2 lots of 2p minus 1 is always a negative integer. Now p can be any value in any number, so let's have a look, and it's only worth 2 marks. It shouldn't involve that much working out to work this out. So let's get started. So first thing I want to do is expand the brackets. So if I expand the brackets out, I get 4p minus 12 minus 4p plus 2. Now collecting the like terms, I can see that my 4p and 4p cancel out, and so what I'm left with is minus 12 plus 2, which gives me an answer of minus 10. Now you might think to yourself, well, okay, there is my final answer, but there you've not actually proved anything. So what we need to write this is a closing statement. So therefore, for all values of p, the answer will always be minus 10. So therefore, will always be negative. Now again, you might be thinking, you think that's a bit of an obvious statement, but it's always worth, whenever you're dealing with any proof question, is kind of just repeat yourself and just state something that says that therefore I've proved what you've asked me to prove. Now there is a sort of Latin sort of notation that you can use, which is QED, which means quad eros demonstratum, which basically means that I've therefore proved what you've asked me to prove. But at GCSE level, I certainly would start by writing this kind of statement, just emphasizing what you've worked out and recalling back to what they actually wanted you to prove. So moving on to our next question, it says that prove that 8 lots of y plus 3 lots of y 2 minus y is a multiple of 5 when y is a positive integer. It's worth 3 marks. So taking out the key bits of information, we want to prove that it's a multiple of 5 when y is a positive integer. So when I'm doing any form of conclusion, I need to make sure that I'm using those two statements in my final conclusion. So again, just like the previous question, the first thing I'm going to do is expand the brackets out. So I get 8y plus 24 plus 6 minus 3y. And then collecting the like terms, what I get is 5y, and it's going to be plus 30. Now at this stage, what you could do is, well, I've got two terms in this particular expression. Well, 5y is a multiple of 5, because anything multiplied by 5 is going to give you a multiple of 5. And 30, which is my second term, or plus 30, is also a multiple of 5. Oh, don't know why I'm writing 10. It is a multiple of 10, but again, that's not what we're proving. So here we're going to write is also a multiple of 5. So here, therefore, a multiple of 5 plus another multiple of 5 will equal a multiple of 5. And therefore, there you have proved what they've asked you to prove. Now, for this, another way of doing it, which again is probably one thing that would be highly recommended, particularly if you want to match your answer very closely to the mark scheme, is with 5y plus 30, what you want to do is show that 5 is a factor, so you can factorize it with respect to 5. So here I can, because I can do 5, I can take 5 out, plus 6. So here, I've got my multiple of 5. So as 5 is a factor, I should say. Oh, let's get the rubber sorted. So as 5 is a factor, the solution will always be a multiple of 5. And there you go. Because if you can divide by 5, then it's definitely going to be in the 5 times table. So either of those two possible answers would be fine. But I would say if you can try and get into the notion of taking out a number 5 from your expression, then that would be a lot easier to explain rather than going for multiples of 5 plus another multiple of 5, which is 30, which is going to give you a definite answer of a multiple of 5. But again, it's entirely up to you how you see these things and what you prefer to do in terms of proving what they've asked you to prove. So moving on to our next example, it says a is a positive integer, and we're going to ask to prove that that 4a squared lots of 2a plus 1 minus 2a squared is a cube number. So again, let's just highlight the key bits of information. So a is a positive integer, and we're asked to prove that it's going to be a cube number. So just like before, what we're going to do is we're going to expand the brackets out. So expanding these two things, we get 8a cubed plus 4a squared, and then minus, and it's going to be 2a squared, which is 2 squared is going to give me 4, and a squared is going to give me a squared. Now from this we can see that the 4a squareds cancel each other out, and so all we're left with is 8a cubed. Now in terms of this, if we break this down, now we can't factorize this, or we could actually factorize this. So in terms of what most people would do is they say recognize that this is 8 times a cubed. Now 8 is a cube number, and a cubed is also going to be a cube number, and if you multiply, and a cube multiplied by a cube number will give you a cube number. So there we have proved one aspect of it. Now as we mentioned, another way of doing it is looking at factorizing. So here we recognize that 8 is a cube number. So what cubed gives you 8? Well, that's going to be 2. What do I need to cube a to get a cubed? That's going to be a. So I can write this as 2a cubed. So therefore, as we can sort of factorize, taking a cube out, if I spell it correctly, a cube out, then the answer when a is positive will always be a cube number. There is our final answer. So there's always two ways in which you could prove whichever statement you prefer, but like I said, in terms of this statement here, this would be what they would expect. And if you've got any ambitions of going on to A level, then this is what an A level and algebraic proof question would look like. However, at GCSE, this would be absolutely fine in terms of this explanation. Now looking at our next question, it says that a and b are positive integers where a is less than b. And the question is asking us to prove that ax plus 3a divided by bx plus 3b is less than 1, where x is not equal to minus 3. So in terms of the important bits of information, that we notice that a and b are positive integers, and we know that a has got to be less than b. And now here we've got this algebraic fraction, and we know it's going to be, we need to prove that it's less than 1. And we also know that it's told me that x can't equal minus 3. So I will come back to as to what this actually means, but this part here of x is not equal to minus 3 is not really applicable to what you are going to be proving. I will explain to you when we're going through this why they need to state this. So looking at this, you might be thinking, oh, what am I going to do? Can I substitute numbers in? As long as a is smaller than b and they're both positive, let's try substitute it in and show that's equal to less than 1. But again, what you want to do is prove this algebraically. Now, in terms of looking at ax plus 3a, and we've got bx plus 3b, then one thing I should be able to spot is, looking at the denominators and the numerators separately, that I can actually factorize the two things. So a common factor in ax plus 3a is a, so I can factorize that with respect to a, and then I get x plus 3. And then if I factorize the bottom, then I also get a common factor of b, so I can take that out, and I have x plus 3 in there as well. Now, because we are dividing, now the one number you cannot divide by is when the denominator is going to equal 0. Now this is where this statement of x can't equal minus 3 comes in, because if x equals minus 3, then this bracket would equal 0, and 0 times b is 0, and therefore we can't, then this becomes obsolete. So you get like a math error because you can't divide numbers by 0. So this is the reason why they write this statement, because eventually you will end up with something, add 3, and it can't equal 0, and you're multiplying, so that doesn't work. So that's the reason why this x is not equal to 3 is written in this particular question. Now going back to the question in terms of this fraction that we've got, I notice that I've got x plus 3 on both the numerator and the denominator. Now because they're multiplying and I've only got a term on each level, I can actually cancel those two things out. So what I'm left with is a over b, and I've got to prove that that is less than 1. Now as a is less than b, then a over b is going to be a proper fraction, because it will never be an improper fraction where it's going to be all top heavy fraction. So therefore will always be less than 1, because if you work out the value of any proper fraction, the answer where a and b are, where the numbers are both positive, then your answer will always be less than 1. And there we've proved our statement. So working on this next example now, this next example involves knowledge of completing the square and quadratic. So if you're not familiar with quadratics and completing the square, then there's no point in you continuing with this particular question, because you definitely need to do it. And I'd recommend that you watch a video on quadratics, and in particular focusing on factorizing and solving with completing the square. So in this particular question, it's asking us to express x squared plus 6x plus 11 in the form of x plus a squared plus b. So first things first, what I need to spot is that this is completing the square. So looking at part A, I've got x squared plus 6x plus 11. So formatting this in the form, what I need to do is set up my x squared plus 11, because that's always going to be the same. Then the number that's inside the bracket is always the coefficient of x divided by 2, which in this case is plus 3. And then I need to subtract whatever digit is inside the bracket squared, so that's going to be minus 3 squared. So just going on to simplify this, end up with x plus 3 squared plus 11 minus 9, which gives me x plus 3 squared plus 2, and there is my factorized form in the form of x plus a squared plus b, where a is 3 and b is positive 2. Now for part B, it says hence prove that x squared plus 6x plus 11 is always positive. Now for this, what we need to do is using completing the square. Now there's one or two ways in which we could do this. So in terms of not using any knowledge of completing the square, but I've got to use this answer because it does say hence. So I've got x plus 3 squared plus 2. Now for all values of x, that this bracket x plus 3 squared has got to be greater than 0. And that's one of the most important things, because obviously, or less or equal to, greater or equal to 0 rather. Because for any value, because you're going to square it, even if x was a ridiculously large, a small number, let's say a negative number like minus 1000, then you'd still end up with minus 997, and if you square that, it automatically makes it positive. So the smallest value that this bracket could ever be is 0, and 0 squared would give you 0. So the smallest that this bracket squared could ever be is a number that's going to be greater or equal to 0. Now when you're adding 2, well, that's always going to be a plus 2. So any number that is greater or equal to 0 plus 2 will always be positive. And that should be enough to get you the 2 marks, because we have used our answer in part A to explain why it's always going to be positive. Now, if you've got knowledge of completing the square and you're aware of how to find minimum and maximum points, that here we're going to have, when we write x plus 3 squared plus 2, that it's going to perform a U shape. It's like a positive parabola. Now, from this, we can then work out what this coordinate here is going to be by using minus a, b. Now, as it's in the form, we're going to have a minimum point at, and it's going to be at minus 3, 2. Now, so its minimum value is equal to positive 2. And as 2 is positive, therefore x squared plus 6x plus 11 will always be positive. Now, if you've got prior knowledge of discriminants, then you can also use the discriminant to show that when you work this out, you get a positive answer, and that would be fine. So then moving on to the next example, which again, we can use a similar sort of technique with completing the square. It says prove that for all values of x, x squared plus 2x plus 6 is greater than 0. Now, to prove this, show that the minimum point is above the x-axis. Now, we know straight away that x squared plus 2x plus 6 is going to produce a positive parabola. So what we're going to do is we're going to use completing the square. So I've got x squared plus 2x plus 6. And again, using completing the square, I end up with x plus 1 squared plus 5. Now, my minimum point for this is going to be at minus 1, 5. Now, if I was to do a quick sketch of that graph, minus 1 is here, 5 is going to be here, 6 is going to be there. The reason why I'm doing 6 is to help me with my graph. And so what will happen is it will look like this, and that minimum point is there. So this therefore proves that as the minimum value is positive 5, then x squared plus 2x plus 6 is always going to be greater than 0. Now, another thing you could always do is show that working with the factorized form is that x plus 1 squared for all values of x, whether positive, negative, big or small, that x plus 1 squared has always got to be a value that's greater or bigger than 0, because obviously that bracket, the smallest it can ever be is 0, and because the reason why is even if x was a negative number, you're going to square it, which automatically makes it into a positive number. So even if the bracket equaled minus 99, by squaring it then becomes positive square of 99. And any number that's greater than 0 plus 5 will always give you a positive value, which is therefore greater than 0. And again, you could use discriminants if you have prior knowledge of that. Now, moving on to this next example, we need some prior knowledge of working with functions. So let me just write down that this question involves functions. And again, if you're not too sure or not covered functions, then this question won't make much sense. So in this particular question, we've got a function, which is this here. And it says that prove that exactly one value for x for when f of x, when this function equals 0. So first things first, let's make the function equal to 0. Is equal to 0. Now here what we're going to do is we're going to expand the brackets. Now, one of the biggest mistakes that most people make is they think that 2x plus 3 squared is going to be 4x squared plus 9. Now this is completely incorrect, and there's always one person that makes that mistake, so just make sure that it is not you. Now, when you have this particular expression, it's important that you recognize that this is 2x plus 3 and 2x plus 3. And if we expand that out, what we end up with is 4x squared plus 12x plus 9. Now, if we then go on to expand this, we end up with 8x plus 16. So if I add those two things together and make that equal to 0, I end up with something that resembles a quadratic equation. Now from this, what we need to now do is go on to solve this, because we want to show that it's only got one solution. Now there's several ways in which we can go on to solve this. We can solve it by factorizing, we can go on to solve it by using the formula, or we could go through the complex route of completing the square, which I would not recommend. So what we need to do is just factorize this. Now if you factorize this, and again if you're not too great on factorizing, there is another video that shows you how to factorize quadratic when the coefficient of x squared is bigger than 1. But what you do end up is with something that looks like this minus the square. And then from this we can then write this as 2x plus 5 squared. Now if we then go on to solve this, I can square root both sides, in which I end up with 2x plus 5 must equal 0, and then I get x equals minus 5 over 2, and that's the only solution that I've got. If I went on to then use the quadratic formula, so a equals 4, b equals 20, and c equals 25, I could go through that route. If it's a non-calculator, then I probably would try and factorize it and recognize that it's factorizing it, but it wouldn't near impossible, but you would be expecting some crazy numbers. Now if you then go on to solve this using the quadratic formula, which is what I'm writing on the screen now, substituting those values, you will also then come up to the value of minus 5 over 2. So here, therefore, as there is only one solution, we have proved what there is only to f of x when f of x equals 0. And there we go. So we can actually forget about the as. Now there is another way. If you've looked at discriminants, depending on if you've taken your mathematics a little bit higher, then you could show that there's only one solution to this by using discriminants. And if you have absolutely no idea what I'm talking about, do not worry. At GCSE level or even at further maths level, there is no need for you to look at that. So moving on to our last example. Now this last example involves knowledge of sequences. So in terms of that, let me just write down sequences. Now reading the question carefully, it says that the nth term of a sequence is a half n and then n plus 1. Work out the expression for n minus 1th term of this sequence. Give your answer in its simplest form. So what we need to do is we need to swap. So for part A, what we need to do is replace n with n minus 1. So replacing that, what I end up with is a half n minus 1 and then n minus 1 plus 1. So all I've done there is swapped wherever I see an n, I've swapped it with n minus 1. So what I now need to do is go on to simplify this, which ends up looking like this. And then I can expand out the brackets, in which I get a half n squared minus a half. And there is my final answer for part A. The next question then says, hence or otherwise prove that the sum of any consecutive pair of terms of a sequence is a square number. So here what we're looking at is that, now going back to what we did at the start of the video, so our two consecutive terms are going to be n minus 1 because we've already used that term, and the next term from that will be n. Now I already know that the sum, so I know that the nth term for this is going to be my answer for part A. So that's going to be a half n squared minus a half. So then all I need to do is swap n for this, which again is just going to prove to be that formula. Now if I just expand those brackets out, I end up with a half n squared plus a half n. I've just noticed that there should be n there. And so all I need to do is add these two lines together. So what I've got is I've got a half n squared minus a half n plus a half n squared plus a half n. Now one thing I should notice that when adding those two, that these two things are the same, they cancel each other out. So what I'm left with is just a half n squared plus a half n squared equals n squared. So therefore it's always going to be a square number for all values of n, because you can end up squaring it, and there is my final proof. So in our final proof question, what this question is asking us to prove that the x squared minus 4 over 5x minus 10 times 10x squared over x plus 2 is always positive, and it's worth 5 marks. Now for this particular question, I need prior knowledge of algebraic fractions. So if you're not too great on algebraic fractions, again I recommend that you get clued up on that, and again there is a video that will be going through algebraic fractions to go through this. So first things first, let's look at this particular component. Now one thing I should notice straight away is this. Now this is a dots question. It's a difference of two squares. So what I can then do is, by factorizing that, I end up with x plus 2, x minus 2. And I can factorize this bottom bit, so that gives me, I can take a 5 out, so that gives me x minus 2, multiplied by 10 x squared over x plus 2. Now when I'm multiplying out fractions, all I do is multiply the two numerators together, which gives me 10x squared, x plus 2, x minus 2, and I multiply the two denominators together, which gives me 5 x minus 2, x plus 2. Now from this I can see that I've got some common brackets, so I can cancel things down. So I can cancel the x minus 2 with the x minus 2, and I can also simplify the x plus 2 and they cancel out. So all I'm left with is 10 over 5 x squared, which then simplifies to give me 2x squared. Now because we are multiplying by because we're squaring and multiplying by 2, so here for all values, so as we are squaring the value of x, then 2x squared will always be positive. And that should be enough to get you your 5 marks. Now I will put some practice questions in the description below along with their answers. Now if you feel you get a proof question while you are revising this particular topic and you have absolutely no idea what to do, then do not be ashamed to have a look at the answers, have a look at the mark scheme to see how they've gone on to prove it. Because with proof questions, at first income, they're quite difficult to prove because you don't really know how to get started, and the mark schemes will usually give you some indication about how to do just that. And once you've got started and once you know how to prove certain things, whether things are positive, negative, even, odd, or multiples, or etc., that most proof questions usually rely on, then you'll gauge an understanding of what it is the question's asking you to do.